Okay, this is what we're going to call the non-math way to balance a chemical equation. The reason why we balance chemical equations is because we have to follow what's called the law of conservation of mass, which says that the total mass of the reactants, which would be everything on the left side of this arrow in the equation, must equal the total mass of the products, which is everything on the right-hand side of the arrow. Okay. In other words, that means that however many atoms of each element I have to be the same on both sides of this equation for it to be balanced and follow the law of conservation of mass. As I said, this is going to be the non-math way to do this. There is a math way to do this that I will show you in a later video, but this method works pretty much for everybody, so this is the one we're going to start with. So let's say that I want to balance this equation. NaCl plus I2 yields NaI plus Cl2. Okay. What I'm going to start by doing is I'm going to draw a line straight through the arrow to separate the two sides of my equation. Okay. The next thing I'm going to do is I'm going to drag down one of each compound that I have on both sides, and if I have something like a subscript 2, like here and here, instead of writing the 2, I'm going to write each individual atom out. So that's going to look like this. So I have NaCl, II, NaI, and then Cl. Okay. Now, law of conservation of mass says these atoms have to match, so the first thing I'm going to do is that I'm going to cross out anything that I see that appears on both sides of the reaction. Okay. That will help me find what it is that's in here that is not balanced. So I can get rid of the sodium and one each of the chlorines and one each of the iodines. So I see that I have an extra iodine on my reactant side and an extra chlorine on my product side. Okay, now, in order to balance these, I'm going to have to create more on the opposing side of the equation. Okay. Now, we cannot just write the atom that I want. So like over here, I can't just write a chlorine. This is a chemical compound. It is chemically bonded. So these two atoms always go together. So if I need more chlorine on this side, then I'm going to have to drag down a whole nother one of these compounds. So I'm going to have to put down a whole nother NaCl here, and that's going to allow me to cross out the chlorines. And yes, it creates another sodium that I have to deal with, but that will work itself out. So if we look here, now I have a sodium and an iodine that I need to cancel out. So here's my sodium and iodine. I can drag a whole nother one of these down. And so there goes my sodium, and then there goes my iodine. And I've got all of my atoms crossed out, so now I'm done. The reaction's balanced. Now, I need to represent how many of each molecule I had reacting total, which we're going to do by using a coefficient, which is a whole number that I'm going to write to the left-hand side of the compound that it goes to. So like here I have 2 molecules of sodium chloride, so I'm going to write a coefficient 2 right there. A little darker. Okay. I have 1 molecule of iodine. Okay, so 1 molecule of iodine, because this is I2, it's a diatomic element, so these two are paired together. So I put a coefficient 1 there. Now, sometimes in chemistry, actually most of the time in chemistry, we don't write 1's coefficients the same way we don't write 1 subscripts if I only have 1 atom reacting. But if, for these purposes, you need to write that 1 there, you can go ahead. Then I have 2 sodium iodine, so I'll put a 2 there. And then I have 1 molecule of chlorine, so we have a 1 there. And so now the reaction is balanced. And this can be read as 2 molecules of sodium chloride react with 1 molecule of iodine to yield 2 molecules of sodium iodide and 1 molecule of chlorine.